Hello students, last class we have studied about the basic character of amines. So we have discussed about what is the basic character of aliphatic amines and aromatic amines. But what happens if any group is substituted at the nitrogen atom of aniline to its basic character? Look here, this is NH2. When N substituted amines are there, then what happens to the basic character? Suppose, so to this aniline, if any alkyl group is substituted, alkyl group is substituted, then the basic strength increases. Then the basic strength increases. Similarly to this nitrogen atom, if aryl group substituted, then basic strength decreases. Then basic strength decreases. That means, suppose we consider about, this is aniline and this is N-methyl aniline and this is NN dimethyl aniline. Then if this is the case, then this is more basic than N-methyl aniline, then aniline. Similarly, if aryl group substituted, suppose phenyl group substituted, this is NH2 group, only aniline, NH C6H5, N-phenyl aniline, and NN diphenyl aniline. So among these three, this one is more basic than this one, because this aromatic group decreases the basic strength of amines. Next, if we compare between aryl amines and R-alkyl amines, then what happens to the basic strength? Suppose you consider aniline and benzyl amine, CH2NH2. If we consider about this, among these two, then this is lone pair of electron. Okay, so this lone pair of electron come into resonance, but here this lone pair of electron do not undergo resonance with this benzene nucleus. So this undergo resonance with this benzene nucleus. So this lone pair of electron in case of aniline is not available and the electron density decreases. But in this case, what happens? This does not go into resonance. In this way, this is more basic than this. So R-alkyl amines are more basic than aniline. So this is the basic strength order. Benzylamine is more basic than aniline. Similarly, another, if we consider, look here, this is NHCH3 and this is benzyl amine. If we consider among these two, this is a primary amine and this is a secondary amine. This is N-methyl aniline. So N-methyl aniline and benzyl amine, if we consider between these two, then this is more basic than this, because here this lone pair of electron again come into resonance. Although methyl group releases electron towards nitrogen, it increases the electron density of this, but this electron pair again come into resonance. As it come into resonance, this lone pair of electron participate in resonance, the basic strength decreases. In this way, although this is secondary amine and this is a primary amine, this is more basic than this. Okay. Now, let us come to some chemical properties, chemical reactions. So, we know that amines contain lone pair of electron. These are bases. As these are bases, they react with acids to form salts. So, amines reacts with mineral acids like hydrochloric acid and sulfuric acid to form salt. So, reaction with mineral acids. Example, C2H5NH2. This is ethylamine. It reacts with hydrochloric acid to form C2H5NH2.HCl or C2H5. This hydrogen comes here. These two lone pair of electron receive the proton. C2H5 NH3 plus Cl minus. So this is ethyl ammonium hydrochloride or ethylamine hydrochloride. We can also say this is ethylamine hydrochloride or ethyl ammonium chloride. Ethyl ammonium chloride or ethylamine hydrochloride. Ethylamine hydrochloride. Similarly, if we take reaction with sulfuric acid, two moles of this reacts with sulfuric acid to form NH3 whole twice plus SO4 minus 2. This is ethyl amine hydrogen sulfate. Ethylamine hydrogen sulfate or ethyl ammonium sulfate, or we can also say ethyl ammonium sulfate. Okay. Similarly, if we take aniline NH2 plus HCl, this forms C6H5 NH3 plus Cl minus anilinium chloride. So, these are bases reacts with acid to form salt. Next, as these contain the lone pair of electron, they also reacts with transition metals to form complex compound like that of ammonia. So ammonia, due to presence of lone pair of electron, it acts as a nucleophile and form complexes with transition metals. Similarly, amines also form complexes with transition metals like transition metal ions like silver ion and copper ion. Reaction with transition metals. For example, CH3NH2, it forms coordinate bond with transition metal. So 2CH3NH2 plus silver chloride, methylamine plus silver chloride give rise to, so it forms coordinate compound CH3NH2 silver NH2 CH3 minus plus and Cl minus. So this is bis methylamine, bis methylamine silver 1 chloride. Similarly, if you take copper chloride, then it forms complexes with this. So Cu in both four sides, CH3 NH2 NHH CH3 and here HH CH3 and here CH3 and H2. So this lone pair of electron form coordinate bond. So it forms coordinate bond with this. This is a complex compound 2 plus and Cl minus 2. So this is also tetrakis methylamine, tetrakis methylamine copper 2 chloride. So this form complexes like ammonia due to presence of lone pair of electron on nitrogen atom. Next, alkylation of amines. Next come to alkylation reaction. So primary, secondary and tertiary amines all reacts with alkyl halide to form quaternary ammonium salts. So this reaction is a nucleophilic substitution reaction. So primary, secondary and tertiary, all type of amines reacts with alkyl halides to form quaternary salt. If primary amine reacts, it forms secondary, tertiary, then ammonium salt. If secondary reacts, it forms tertiary and ammonium salt. If tertiary amine react, it forms quaternary ammonium salt. So look at these equations. Suppose ethylamine reacts with ethyl bromide. Ethylamine reacts with ethyl bromide minus HBr. It forms diethylamine. It forms diethylamine. Here one H, here one Br. So this is removed. This is nucleophilic substitution reaction. In place of Br, C2H5NH is substituted. This is diethylamine. So ethylamine diethylamine. Then this diethylamine again reacts with ethyl bromide. Here also minus HBr, 1H here, 1Br here. It forms whole thrice N. This is triethylamine. Triethylamine. Again this triethylamine reacts with alkyl halide to form whole 4N plus and Br minus. Tetraethyl ammonium. Tetraethyl ammonium bromide. In place of ethylamine, you can write the reaction for methylamine also. Methylamine, methyl iodide, if you take, first gives dimethylamine, then trimethylamine, then tetramethyl ammonium iodide. Same type of reaction. So I have given only one. Okay. So if only primary, it gives mixture of secondary, tertiary and quaternary ammonium salt. If you take only secondary amine, it gives tertiary amine and this ammonium salt. And if you take only tertiary amine, then it gives this quaternary ammonium salt. In the same way, the aromatic amine also reacts in the same way, like that of alkyl amines. Look at the example of aniline. So when aniline reacts with methyl iodide, NH2, suppose I am taking here methyl iodide, here minus Hi, here one H and one I, it forms NHCH3. And this NHCH3 again reacts with CH3I minus Hi. It forms this is aniline. And CH3 whole twice. This is NN dimethyl aniline. And again it reacts with CH3I. Remembering third step, in last step there is no elimination of Hi, no removal of Hi. It gives rise to NCH3 whole thrice plus I minus. This is trimethyl anilinium iodide. Trimethyl anilinium iodide. So this is alkylation. An alkyl group is substituted as this nitrogen atom. Next come to acylation reaction. Acylation of amines. So amines, generally primary amine and secondary amine, no tertiary amine. Okay, generally primary amine and secondary amine reacts with acylating agent like acetyl chloride and acetic anhydride. Acetyl chloride and acetic anhydride to form N substituted amides to form N-substituted amides. So primary amine and secondary amine reacts with acid chloride and acetic anhydride to form N-substituted amides. Remember, tertiary amine do not show this reaction because tertiary amine have no hydrogen atom attached to nitrogen atom. Look here, equation C2H5NH2 plus CH3COCl. So to this NH2, I can write like this, NH and CH3COCl. It gives rise to, so minus HCl is there. So it gives CH3CO NH C2H5, CH3CO NH C2H5. So this group comes here plus HCl. So CH3CO, this is the main functional group, and the nitrogen and ethyl group is there. So name of this compound is N-ethyl acetamide. N-ethyl acetamide. Similarly, if we take secondary amine NH plus CH3COCl. Actually, this reaction takes place in presence of base. In presence of a base, this reaction takes place. HCl give rise to same CH3CO and C2H5 whole twice plus HCl. This is NN diethyl acetamide. Similarly, if the reaction takes place in presence of acetic anhydride, C2H5NH2, this is ethylamine, diethylamine. Remember to write the name. Ethylamine plus acetic anhydride. So 1H bond breaking takes place, suppose here. So one hydrogen atom, suppose I am writing NH2. This part gives an acid and this part. So it gives you CH3CO NH, CH3CO NH, C2H5, C2H5, CH3CO NH, C2H5 plus this part CH3COOH, CH3COOH. This is N-ethyl acetamide. This is ethylamine given. You can write the reaction for methylamine also. Same reaction also given by aromatic amines, that is aniline. Tertiary amine do not respond this test. Remember, tertiary amine do not respond this test. But here, if you take acetyl chloride, so aniline reacts with acetyl chloride in presence of pyridine. A strong base required, either pyridine or sodium hydroxide. Here also same way, hydrogen 1 and chlorine. So it forms, removed minus HCl, so it gives NHCO CH3 plus HCl. This is N-phenyl acetamide, also known as acetanilide. Acetanilide. Similarly, when aniline reacts with acetic anhydride, it reacts with acetic anhydride in presence of sodium acetate. Remember, if you take any acid, then the sodium salt of that acid you have to take. So aniline, if you take any acid anhydride, then you have to take the sodium salt of that acid. So aniline reacts with acetic anhydride, this is acetyl chloride. So aniline reacts with acetic anhydride in presence of sodium acetate to form same reaction NHCOCH3. Here one hydrogen comes here, so plus CH3COOH. This is acetanilide or N-phenyl acetamide. Okay. Next, come to benzoylation. Benzoylation of aniline. So aniline reacts with benzoyl chloride. Aniline reacts with benzoyl chloride. So when benzoyl group is substituted at this nitrogen atom, and this reaction takes place in presence of sodium hydroxide, a strong base. So aniline reacts with benzoyl chloride. This is benzoyl chloride in presence of sodium hydroxide to form NH. So here also H and Cl removed. NHCO C6H5. NHCO C6H5. This is N-phenyl benzamide plus HCl. N-phenyl benzamide. N-phenyl benzamide. And this benzoylation reaction. So reaction of phenol or aniline with this benzoyl chloride. So benzoylation takes place. Benzoyl group is substituted. Benzoylation takes place. So this benzoylation reaction is known as Schotten-Baumann reaction. This reaction is known as Schotten-Baumann reaction. When aniline reacts with benzoyl chloride, instead of this figure we can write C6H5. When aniline reacts with benzoyl chloride, it forms N-phenyl benzamide. This reaction is known as Schotten-Baumann reaction. Okay. Next, come to reaction with Grignard's reagent. Reaction with Grignard's reagent. RNGX. This reaction is also given by primary and secondary amines. So primary and secondary amines which have active hydrogen atom reacts with Grignard's reagent to form alkane. Tertiary amine do not contain hydrogen atom or nitrogen atom, hence that do not react with Grignard's reagent to form alkane. So look the equation. Suppose I have taken here, okay, C2H5NH2 ethylamine plus, suppose methyl magnesium iodide is there. What is the group here? Methyl group. So this methyl group reacts with this hydrogen. Alkyl group here reacts with this hydrogen to form alkane. It gives C2, it gives CH4 plus C2H5NH MgI, ethylamine magnesium bromide, ethylamine magnesium bromide plus methane. This is ethylamine. If you take methylamine, CH3NH2 plus C2H5 MgBr, ethyl magnesium bromide, and this is methyl amine. What is the alkyl group here? That only gives alkane. So here it gives C2H6 ethane. This alkyl part react with hydrogen to form alkane plus side product CH3NH MgBr, methyl amine magnesium bromide. Okay. Similarly, secondary amine CH3NH plus C2H5 MgBr. It also gives C2H6 plus CH3 whole twice N MgBr, dimethyl amine magnesium bromide and ethane. So these hydrogen atoms are active hydrogens in this primary and secondary amine. This is methylamine, this is dimethyl amine, reacts in the same way. Okay. Next come to reaction with aldehydes. Reaction with aldehydes. Next come to another reaction, that is reaction with aldehydes. So both aliphatic and aromatic amines reacts with aldehydes to form Gibbs base. That is also called amines. Look at the example. NH2 plus so ethylamine reacts with ethanol or acetaldehyde. Here removal of water takes place, gives C2H5N double bond CH3. This is ethylidene, ethylamine. This part ethylidene, ethylamine. Similarly, this is aliphatic. Aromatic amine also reacts with aromatic amine. That is, suppose you take aniline, reacts with benzaldehyde to form minus H2O. This is one type of condensation reaction. give rise to N double bond CH C6 H5. This part is 6 is H5. So the name of this compound is benzylidene aniline. Both are Schiff's base. These are known as Schiff's base or anils. This is also a Schiff's base. These are known as Schiff's base. Some different examples. One is ethylidene ethylamine and another benzylidene aniline. Next come to another important reaction. That is reaction with chloroform. Chloroform, also called carbyl amine reaction. So this is only given by primary amine, whether aliphatic or aromatic. So the primary amines, aliphatic or aromatic primary amines, reacts with chloroform in presence of alcoholic potassium hydroxide to form alkyl isocyanide or carbyl amine. This reaction is known as carbyl amine reaction. Look at the example. This is the general equation. This is primary amine. Here R may be alkyl or aryl group, reacts with chloroform in presence of alcoholic KOH, potassium hydroxide. When this is warmed, it gives rise to RNC, alkyl isocyanide, plus 3 potassium chloride plus 3 H2O. Okay, so this is alkyl isocyanide. This alkyl isocyanide have very foul smell, bad smell. So this is a very unpleasant smell, that is intolerable. Okay, so example, methylamine, ethylamine, all primary amine. C2H5NH2 ethyl amine reacts with chloroform in presence of alcoholic potassium hydroxide. When this is warmed, gives, what is the alkyl here? N and C1 comes from this chloroform. C2H5NC. You can write NC or N bonding structure, or directly you can write NC plus 3 KCl plus 3 H2O. This is ethyl isocyanide, also known as ethyl carbyl amine. That's why this is called carbyl amine test. One carbyl amine is formed. So that's why this is called carbyl amine test. Ethylamine, methylamine, all primary amines give this test. Secondary amine and tertiary amine do not respond this test. Look at another example. Suppose you take aniline. Aniline, benzylamine also respond this test. This is aniline reacts with chloroform in presence of potassium hydroxide, alcoholic potassium hydroxide, to form warm or the heat give rise to phenyl carbylamine or phenyl carbylamine. This is aniline, phenyl carbylamine or phenyl isocyanide plus 3H2O. Okay, so this is only given by primary amine. Secondary amine and tertiary amine do not respond this test. Secondary amine and tertiary amine do not respond this test. That's why this test is used to distinguish primary amine from secondary and tertiary amine. This is the test only for primary amine. So this is the test only for primary amine. Secondary and tertiary amine do not respond this test. So this is used to identify primary amine from other amines, that is secondary and tertiary amine. And this alkyl isocyanide have a very foul smell which can be identified easily. Next come to reaction with carbon disulfide. So this is also given by primary amine. Okay. This is also known as Hofmann mustard oil test. This reaction is also known as Hofmann mustard oil test. Okay, so aliphatic primary amine reacts with carbon disulfide to form some substituted carbonic acid, that is alkyl thiocarbonic acid, and this carbonic acid decomposed with mercuric chloride to form alkyl thioisocyanate. So this compound has some mustard oil like smell. That's why this is called mustard oil test. Okay, first look at this equation. Plus carbon disulfide. Carbon disulfide has similar structure like that of carbon dioxide. It forms an addition compound. So H comes, this bond breaking takes place. This H comes here and C2H5NH comes to here. In this first it gives C2H5NH, C double bond S and SH. This bond polarization takes place and hydrogen comes here. This C2H5NH group comes here. This is known as dithioethyl carbonic acid, which decomposed with HgCl2 to give C2H5NCS. This is ethyl isothiocyanate plus HGS. So this compound ethyl isothiocyanate, this ethyl isothiocyanate, it has mustard oil like smell. That's why this test is also called mustard oil test. Mustard oil test, or we can say Hofmann mustard oil test. This is also called Hofmann mustard oil test. This is ethyl amine. So aliphatic amine reacts with this to form carbonic acid, substitute carbonic acid, which decomposed with HgCl2. It requires some warming. Hg mercury chloride to form ethyl isothiocyanate. Aromatic amines reacts in a different way to form this aryl isothiocyanate. Look at the equation. C6H5NH, C6H5 NH and H. This is aniline reacts with. So removal of H2S takes place. Then when it is heated with solid potassium hydroxide, it forms C6H5 NHCS NHC6H5 plus K2S plus water. So aromatic amine or aniline, when bound with carbon disulfide in presence of solid potassium hydroxide, it forms N-phenyl thiourea. This is N-dash diphenyl thiourea. Urea structure CONH2NH2. Instead of oxygen, sulfur is there, so thiourea. N-dash diphenyl thiourea. And when this compound is warmed with, heated with hydrochloric acid, when it is heated with hydrochloric acid, it forms phenyl isothiocyanate. C6H5NC double bond S plus C6H5 C6H5NH HH NH3 plus Cl minus. This is a salt and this is phenyl thiourea. So aniline, when warmed with, heated with carbon dioxide and solid potassium hydroxide, it forms N-diphenyl thiourea, which decomposed with hydrochloric acid to form phenyl thioisocyanate. This reaction is known as Hofmann mustard oil reaction, and this is only given by primary amines.